Come, all you moonshiners, if you want to hear.
Well, welcome back to Barley and Hops. I'm George. We're going to do a tutorial on wiring a PID. Oh, based on a lot of feedback that I've been getting, the PID tends to be a hot topic. I've got a lot of wiring diagrams coming in back and forth, and what I thought was that we did this years ago, so there's a playlist for controlling heat in your still. You can use this to control the heat in a still, a fermentation chamber, a powder coating oven, whatever system or process that you're trying to control, precisely control temperature, the PID is a really good source for you. A really good choice. Now, there's also a pulse width modulator, a PWM. You could use that as well, and I've got videos on that. Just go back and search through our playlist or search through the channel. You'll find all of this information. But I thought it interesting or important enough to do a real quick wiring diagram to just kind of unlock this, because it really is that simple. Now, my preference is the Inkbird ITC 106 VH. And that's the model of, it comes in a box, looks just like that when you get it from Amazon. You can get them for, be cautious about knockoff models. That's all I can say about that. But it comes in a box. It comes with your PID controller. Oh my goodness, it comes with this one in particular, and this is the one I'd like to use because it's kind of universal. It's rated up to 40 amps, so it's the solid state relay SSR 40DA. Okay, they also make an AA. You need the DA because you're going to use DC to control AC. Okay, an AA is using AC to control AC, and in this particular, they're matched up when you order that. Okay, so just order off of Amazon and type in ITC 106 VH, and that's what will come up. Of course, with many different options available. It also comes with a heat sink and your thermocouple with a small stubby end for your sensor. You can use that, or you can, if you like, you can order one with a really long sensor, so a probe, so you can stick it down in the top of your column. All of them will work. My goodness, they even come with, you can get up as far along as 18 inches. I mean, they come in many different varieties, but they all do exactly the same thing. Okay. When we're wiring a PID, all we want to do is make sure we get power to the right places in a safe manner to do the right things. A lot of people will open this up and look at this. They'll see the wiring diagram on the side because it's Greek to them. You know, it's brand new. Don't let that confuse you. Please don't let that scare you off. You'll see all of the screws on the bottom, and they're all numbered. Don't let that scare you off. Okay, it's not that hard. Okay, this is what we have. We're going to do wiring 120 volt PID. And we're just going to, without any of the options, without any of the cool point things, like a volt amp meter, like a switch, like the lights, like a fan, we're not going to do any of that. We'll add that. Why not just add that after we wire this? So when you're drawing your own diagram, you can draw it out how you need to wire it, and you can start adding your components. This is going to be wiring 120 volt PID, all right? And this is good for up to a 2,000 watt element. Anything larger than 2,000 watts, 2 kW, you're going to need 240 volts. They don't make them any larger than that for 120 volts. And this is standard household power. Now this is good for this system that you make will be adequate in order to run about an 8-gallon still. That's perfectly okay. Now, anything larger than 8 gallons, you're going to need a little bit more oomph to get it going, okay? Now, we're going to be talking about voltage and amperage. You got to think about voltage is sort of like the powerhouse, the power, the oomph. And that's voltage. The amperage is the force in which that oomph is applied, okay? So, sort of like speed, in a way. Yeah, that's one way of looking at it. I mean, it gets a little bit more technical, but that's a simplistic way of looking at it. All right, these things, of course, this one I've got it, had it plugged in, so it plugs into a standard household. So here's my plug. So you have to kind of envision this. 120 volts has has only 3 main wires. Okay, one is sort of like a dead giveaway, and that's the ground. Okay, so we'll use green for that. All right, this is our plug. Okay, that's our 3-prong plug. And so we've got a green wire that comes off of here. And where does that go? That's a ground. And you got to follow this green wire. This green wire runs all the way over here. And you connect that to the chassis or to the still, to any other end point in your system, because you just need a ground. Now, incidentally, this is sort of like convention. The convention in electrical wiring is black is hot. Okay, black is your main hot wire for 120 volts. So we've got 120 volts here, and white is known as the neutral wire. You following so far? Yeah. The neutral wire. I'm going to use blue because you'll never see white on the board. So blue is my neutral wire. Neutral. Okay, now the reason that you're going to need a neutral is neutral allows your electricity. You see, what happens when you connect a hot wire to an element or a device that's supposed to run? Well, nothing, because your electricity only goes so far and stops. It doesn't go anywhere. It needs a path back in order to make what they call, you've heard this, the complete circuit. Well, your neutral allows you to have that complete circuit. So as long as you've got energy going in a complete circle, then you've got flow. You have amperage. At this point, you only have voltage. Okay, so you've got the horsepower, but you don't have any flow until you connect it to a neutral. So you got to give it a place to go. It will be utilized at the point that you connect it, but you still got to have that flow for the current to return or the voltage to return. All right, this is so rudimentary and so simple. The first thing we're going to do, see, we're going to wire, what are we trying to make work? We need to make the PID work. The solid state relay is nothing more than a smart switch. So you don't have to wire that yet. And we need to make the element work. So we want to get the power from here to here, but in the meantime, we want to control it. We're going to use this device to control it through this switch to work that. All right? So as you're drawing your diagram, the first thing we want to connect is your major power and high amperage lines. Now, you're going to draw probably 12.5 amps or so with a 1500 watt element. You'll probably draw 15 amps, maybe 16 amps with a 2000 watt element. So you're going to need to use at least 12 gauge wire. It's called AWG, American Wire Gauge. So 12 gauge wire is sufficient. If you use 14 gauge wire, which is standard for normally lighting and stuff like that, you may run into a problem, because what happens when you increase amperage in a conductor? The byproduct is heat, and that's why fuses work, because they use, no. So you need to make sure you have the proper wire size for that. So the only thing that you need, the only place that you need your 12 gauge wire in this particular case, if you wanted to be super good about it, use 10 gauge wire. That'll handle 30 amps. But the only place that you need it is in your major the major portion of your system, which is here. Okay, so the first thing we're going to do, we're going to run our neutral wire. We're going to run that sucker all the way over, and we're going to connect it to one end of the element. So far, so good? Right. Now, that's the path back. We're going to need 120 volts on this other end. What would happen if I connected this to this and then plugged it in? Yes, that heating element would come on. because you would have 120 volts going to it and you'd have the neutral that returns a complete circuit. We want to use the switch to get here. Okay? So we're going to run the 120 volt line. We're going to run that one over to pin number 1 on the solid state relay. On the solid state relay on pin number 1. And you'll notice the little symbol there, it's broken, which means it's a contactor or a switch or some sort of connector. And then we're going to run another wire from pin number 2 to the other screw on your heating element. Or whatever you have on this end. Right now, if I plug this in, that heating element is not going to come on. It will not come on because this connection has not been made yet. Okay? We're going to use these 2 pins with electrical signal to make this connection, which is just like closing this and causing that heating element to come on. What do we need now? Okay, now we need smaller gauge wire. We can use 18 gauge, small, just because we're only carrying DC voltage, direct current. And it's a really small amount. It's a really, really minute amount of amperage. So the byproduct being heat is not a concern. You can just use a small. I'll use red on this. Okay. So now we run a small wire from pin 6, which is also a negative pin, to pin 4. Pin 8 is a positive pin, and we run pin 8 to pin 3. Now what that does is connects the PID itself to the solid state relay. So if we have a signal on these 2 wires to these 2 pins, that light comes on, which means that this connection is made and that element comes on. All we need now is to make the PID work. And on the PID, we have pins 9 and 10 are your power in. Now, when it comes to AC voltage, it's not polarity specific in this particular case. So what we need is, and the PID only draws 0.5 amps. It's a small amount. Where's our first? We have power going in. So our first point of power of 120 volts is actually at pin number 1. We can actually do it from back here. We can do it from anywhere in this line. We can jump off of this line to get 120 volts. Make sense? Yeah, so anywhere along this line you have 120 volts going. So we can go from here, we can take it from back here, or we can take it from pin 1, and we only need a small gauge wire because, again, the PID only pulls like 0.5 amps, so it's such a small amount. So I'm going to run a small wire from pin 1, and this is the symbol for jumping over a wire. And I'm going to go to pin number 9. You could go to pin number 10 if you wanted to. Just don't put them both on the same pin. And then, all I need now is a neutral. Oh, where's my neutral at? My neutral is anywhere in this line, or from here. I can take it from way back here. I can splice into here. I can take it from that point. But that's my neutral line. So I'm going to take it from here. I'm just going to splice in here with a small gauge wire. And go to pin number 10. I'm wired. This will work, well, provided that, of course, you have the feedback. What's the feedback mechanism? It's the thermocouple, your probe. And your probe is marked with a red and a blue, red for positive, blue for negative. And we have a positive and a negative on terminals 3 and 4. Terminals 3 and 4 are for your thermocouple. So what I'll do, real simple. This is called this TC thermocouple. A positive line, it goes to pin 4. And I'll use blue again. The negative line goes to pin 3. And there you go. Now, we've just wired this directly. All we have to do now is plug it in. Your PID will come on. It will start sensing temperature through the thermocouple. Right? So when it senses that temperature, if the temperature is lower than what you've set on the PID, it sends a signal through pins 6 and 8, activates your solid state relay, closes the switch, and turns on your element. During the time that it's running and your element's running and your system starts to heat up, when your thermocouple senses that the temperature has achieved this temperature, it will discontinue this signal, turn off this red light, open this switch, turning off your heating element. It's like unplugging it. It just turns it off. And so this happens over and over and over again. Now, just a real simple theory about PIDs, how they work, is your PID, once you set the parameters in the PID, all it does is it tracks and it graphs the temperature, and the temperature rise over a period of time, and it starts to predict when and where to turn on and turn off. And so that what that does is it only applies the amount of power necessary to maintain the temperature you've set. Once it gets close, it knows that it's been rising at 1 degree per 5 seconds over the past period of time that you've got it set for your parameters. And so that I need to turn it off now so that it will achieve that, called the band of excellence. What you want it to do is you want it to kind of level out at that point. And it'll do that. And then as it starts, it notices it when it starts to drop, and it knows how much it'll turn on and off, on and off, on and off. And so it starts to work similar to a pulse width modulator, because if you can time the amount of energy going in and out on a predetermined time, you're actually reducing the overall voltage. Oh, see, I'm getting way too much into the theory. But that's, for sake of argument, if you set this at 173 degrees, 185 degrees, 190 degrees, your heating element in your system will achieve 190 degrees and then maintain that on its own without you having any input into it whatsoever. That is 120 volts, start to finish. Okay, we've wired this 120 volt PID. And now as you build one of these, you can build it in the box if you like to. You can put it on a piece of wood, a plank of wood, and just kind of mount your items on there and mount them in order. It's that simple. But if you want to kind of like push up the cool points, you start adding little things to it. You want to start tracking the wattage, the voltage, the amperage, and things like that. You can add a volt amp meter. And a volt amp meter it's really small, and this one is a model PZEM-061. Again, Amazon has oodles and oodles and oodles of these, and it has, if you start to read the description, it'll tell you that it can sense in a range of this to this, So it comes with just the meter itself, a small, I call these a donut, but this is the actual sensing element. It's a sensor, and 2 wires. So easy to add into your system. What do you need for this? You need 120 volts. Where do you have 120 volts? You've got 120 volts anywhere along these 2 lines. Anywhere. Oh my goodness. How much easier could this be? I'm gonna draw this over here, but it could be anywhere. You've got your volt amp meter. And what you need is a hot wire, a 120 volts. I guess what? I got it right here at pin 9 because when I plug it in, it comes on. So I've got a hot at pin 9. I can just take another small wire and hook it to one of the voltage ends on your volt amp meter. And I can take another wire from pin 10 because as soon as I turn this on, this is going to be energized. So I go here It goes to the volt amp meter. Now, when I plug the system in, not only does the PID come on, but you'll notice I got 2 wires that go from 9 and 10. They go to my volt amp meter. My volt amp meter is going to come on with it as soon as I turn it on. My volt amp meter's working. Could I have taken my neutral from here? I sure could have. I could have taken my neutral from here. I could have taken my neutral from back here. All of those are options. You see, that's why I say there are hundreds, or not hundreds probably, but there's several different ways in to actually wire one of these. As long as you just remember, we went 12 gauge wire in this particular case, 10 gauge if you want to get happy. And we went to our element, and then we start working our way back. We start adding components. We're just adding one more component. Now, our sensor has 2 wires, and it shows you on here, it's got 2 small pins. You just unscrew it, put them in, screw it down, and you've got your little donut. Your donut goes around, and these are red and black, so we're trying to measure current. We're going to be measuring voltage the whole time. Now we just want to measure current. So as we measure current, we want to place it around our highest current carrying conductor, because that's the one. I'm not really concerned with what the current is here, because I know that this is low current. It's the draw and requirement. Remember, current only flows through a conductor based on what the device requires, is pulling for, drawing. And this is so low, as I don't need to know what that is. I'm worried about or concerned about what this is. So it goes around one conductor, your donut. I call it a donut, but it's a sensor. And then you'll have one black wire that goes here, and the other one is the red wire, which goes here on the back of your meter. So now you have a complete system with a volt amp meter. You've just added that component. What's another component we could add? Well, by golly, we could add a receptacle, because you may not want to have this just plugged in or just wired in permanently. You may want to have a receptacle. It makes things so simple. Let's disconnect this wire, disconnect this wire, and we'll place a receptacle right here. And we're going to wire this to one side of that receptacle. So you got a hot wire on one side of the receptacle, and you've got a neutral wire on the other side of the receptacle. So what happens when you turn on or you plug in your PID? Well, your PID will come on, your volt amp meter will come on, everything will be operational, but it won't be going anywhere until you do what? So you've got a plug here, you put a plug on the end of this, and you plug it into your receptacle. And now your element works. What is another accessory you can add to this? Well, you can add a switch right here, which I normally use a 20 amp rocker switch. And so what happens is you've got you wire one side of the switch and wire the other side of the switch, and your switch is in the center. So now you plug it in, nothing happens till you turn the switch on, which energizes. So you see how simple this becomes? There are so many different accessories that you can add to this system. It just makes it that much more appealing to you, and however you want to design it, however you want to make this. Again, you can put it in a small box, you put it in a large box, you can mount it on a plank of wood. In any event, as long as you just follow these simple rules, how to wire your PID for 120 volts up to a 2,000 watt element. I almost forgot. You know, now for those of you who are you're gonna build a box, You know, and you've got your solid state relay mounted on your heat sink, because that's what it's for. And you've got high, again, remember, the byproduct of amperage is heat. And so your heat sink dissipates the heat developed inside your solid state relay. Now, this is a reason why it's good to mention at this point. See, if you have a small solid state relay, will it work? Yeah, it probably will, but at some point it starts to heat up because of the amperage that goes through it. That's why I get a 40 DA. They come with 25 DAs. A lot of times a 25 DA will work well up to this point with a 2,000 watt element, but anything larger than that, the heat is a byproduct of the amperage, because you're starting to exceed the amperage it's rated for, and it'll burn up. But what the heat sink does is the heat sink dissipates the heat that's developed in the switch. That's what it's there for. Now, to aid that, a lot of times, if we do it in a box because it's an enclosed environment, we'll add a small fan. And the only thing a fan does is it causes circulation across that heat sink. And then to add one of those, what do we need? Well, we need, this is a small 5 volt, and it's got a small USB connector on the end. Again, there are oodles of options on these things. You can get them in a small fan like this, you can get a large fan. There's so many different options, it's totally up to you. If you're going to mount this on a board out in the open, chances are you're not going to need a fan, because you're sitting out in the open in the environment, and your heat sink is going to dissipate all that heat. But if you're in an enclosed environment, you want to have some sort of ventilation that's going on inside the box to keep it cool. So you add one of these. To add one, I just use a small cell phone charger. You can go on Amazon, you can get one of these, or you can go on Amazon, you can also buy a 5 volt transformer, 120 volts to 5 volts. You can do that as well. Those are a little bit more expensive. These are a couple of bucks. You just use small connectors, the blades, and connect them here. What do I need to make this work? I need 120 volts. Where do I find that 120 volts? Let's look. Where can we get 120 volts? My goodness, we've got 120 volts available just about anywhere. We can tap it from here and here. That's one place we can get it. We can tap it from here and here, but we've already got, you know, it just kind of bunches it up. But so I can tap it from here. There's also 120 volts and a hot and a neutral here on my switch or on my receptacle. I can do it there. I can do it back here on the switch, wherever I've got 120 volts available. I just want to have 120 volts in the fan come on when I turn the system on. So I want to go in these, somewhere in these lines, somewhere. And the one that comes to me, the quickest one, or the most obvious one, is really the receptacle, because I know that, no, that doesn't, because that only works when the solid state relay is working. See how easy that was to determine? You go, no, that receptacle is not going to be hot unless my thermocouple tells my PID to send that signal. So I got to find somewhere, heck, I'll just take it from here. I'll just jump 2 wires from here and here. Or I could go from pin 1, and I could go from the other side of the receptacle. I could go from pin 9 and 10. I go from pin 1 and pin 10. I could go from here, and I could jump in here. You see, the options are endless. Let's make this simple. I'm going to put the transformer right here. Transformer. I'm going to take one wire and go to one side of one of the blades. And I've got the other blade here. Yes. I'm going to take one from here and connect to that blade. Now, when I turn on my system, I'm going to get power that's going to run through here, power that's going to pins 9 and 10, power from 9 and 10 to my voltmeter, power from my voltmeter to my transformer. All I've got to do now is not drop stuff, is plug in my fan, via the USB cable. So when my power comes on, everything is energized, and that fan will start to operate. That's another accessory or component of your whole system. But you'll notice how none of the system changed. I'm adding to it now. I'm adding to it. Let's move on to the 240 volt. And you know, I thought about leaving this and then just adjusting. I said, no, there's some people that might want to go straight to the 240 volt system and skip this because they know this. I agree with you. Let's start over.